educational videos on biogas by Hycons.
We are on fourth session, which we thought we'll do it on a raw material selection part because that is the primary and basic activity. And raw material is going to decide the success. The rest of the things, machineries and those, apart from all other this one. So, and our research entirely on lignocellulose biomass. So, the most common ones I have chosen. First one is the cow dung, which is very famous and very easy to digest. But if you look at how will you collect so much of cow dung when it is giving only 54 meter cube kind of methane. So that is very difficult work. The poultry gives a better this one. Again, the collection and gathering is very difficult. And because of so much of ammonia, there is huge amount of smell which get created in your CBG plant. Then you can feed fresh grass. Again, it can be used, but there is no specifically we cannot control the proteins or sugars in the fresh grass. So whatever you get, you will be feeding. The paddy straw is available in some of the geographies, and some places it get used as fodder. So it's some places it's costing very huge amount of money per ton, 7,500 rupees, those kind of thing. And when you store this, there is a huge risk of fire because there is a very dry kind of material. Then coming to the press mud, which is again one of the largest in the picture as of now. Before the Napier got into picture, now if you look at today, that is in July of 2023, you will see that a lot of people are talking about Napier. The press mud is generally a very good substrate for the people who are owning the sugar factories. So most of the sugar factories are going for their own CBG plants. The advantage with the prismat is it gives a very high yield of gas when it is fresh. But the disadvantage is sugar factories run for only 6 to 7 months in a year. And if you store the press mud, the sugars will fly away as it is, even in the open air or if you cover it. Then, as it gets older, the output will come down to half of it. And there is so much of hydrogen sulfide which will get produced, which can be like 3,800 ppm, whereas in Napier it will be maybe uh, less than 20% of that. And there is a sludge formation below the digester, so you'll have to do the digester above the ground only, and the insulation will be required that time. Then we have municipal solid waste. This is a slightly tricky case where you need a right contact in the government circle to gather and manage this. Typically, municipal solid waste is collected by the municipal contractors, and sometime it will become very difficult to approach them or work with them. Uh, as I said, it is a little tricky space, and there will be a lot of plastic and glass mix which will come in, and the output is slightly unpredictable. Whatever the homogeneous mixture you make it, one day a lot of tomato, other day a lot of aloo, other day garlic, those challenges will come. But otherwise, this is available mostly free of cost, and sometimes municipality themselves are ready to pay for processing this material. So this is one of the option. Then Napier, as it is, if you chop it and put it, also you will get a traditional yield. Uh, so that is not a problem. Only problem you have to solve is it should get into the water. It should not be floating. So if you find a methodology to uh, mix with the water and find a methodology to send it into the digester, then the carbohydrate and sugar, whatever is available in this, will give you the gas. Then in our case, we do this traditional output we get anyway from the direct sugar and carbohydrates, and we also attack the fibrous part of the Napier grass. That's why our yields are higher. So there is nothing like magic. We do the traditional process as it is goes on. It will give you whatever 60 70 meter cube of biogas. Then you will have the fibrous part which are converted to sugar, and that also we use. So that's how we are getting a better yield. And because we are digesting the fibrous part, the solid fertilizer fraction will be very less. So solid fertilizer, even though it has a good value, again you will have to set up a supply chain to sell it. So it is always better to remain as a gas company than becoming a fertilizer company. And that whatever liquid side digested comes and whatever small amount of solid comes, that will go back to Napier field as a fertilizer. So we can avoid the external fertilizer fully. So that way it becomes a completely circular economy. Apart from Napier, we can work with any kind of grass kind of material, which is lignocellulose biomass. We can also, of course, do press mud and cow dung, which is a very easier process in compared to Napier or paddy straw and those kind of things. And when we say Napier, it can be as I told, any grass family like bamboo, maize, and sunham. So, what is the logic behind this higher yield and lower yield? That we have to understand. So, some materials give a better yield, some gives a lower yield. So, it is once we have the concept in mind properly, it is easier to decide on. Now, let us say for all our survival, sun is the energy, indirectly or indirectly, whatever way. And the sun's energy is captured by the primary material like a plant. And these primaries will have a lot of carbohydrates. Then people like us and also the animals, they will eat this primary material and either they will consume for their own survival, or they will accumulate. So these substrates will have a lot of protein and carbohydrates. Both are there in this. Then after this processing, the excretion is always our cow dung or the poultry. Uh, all those things are basically the secondary kind of waste because it is already went through a process either through an animal or through a machine. So whatever passes through an animal or machine, the energy potential is already taken out to a large extent. So because of this secondary thing, this will be costing less, but at the same time they will have a very low energy potential also. Why that happens? Now, if you look at here, the biogas finally it is not coming from Napier or paddy or anything. Biogas is coming always from a glucose. So whatever we bring it to the glucose form, the gas will get formed. The glucose plus glucose, when we add it, we call it sugar. And multiple kind of sugar, we call it carbohydrates. And carbohydrate and fatty acids with nitrogen and carbon mixtures, this is called protein. And multiple kind of proteins, and when it more complex it becomes fat. So that way the pyramid is there. So the second basic understanding what we have is, if we enter in this the below the pyramid we go, it will be little complex to digest. But at the same time, once we take out that complexity, you will start getting higher gas yield. So if you feed directly glucose, you may get a very good gas, but you will have to put tons together of glucose. So whereas the same 1 gram of fat may contain more glucose if we convert it. So 1 gram of fat is more valuable than 1 gram of glucose itself. So that is how the energy pyramid works. Based on this, the raw material selection has to happen. This raw material selection session, let us close it for now. Then we'll again catch up for the next session, which we are thinking is basically the biogas production process. Thank you.